Hello, and welcome to my YouTube video for my final project presentation for microprocessors lab class 238 at Olympic College. My name is Sam Wazalowski, and this is my final project using the PIC16F887 microcontroller 8-bit chip. For my project, as you can see here, I constructed a voltage regulator using a solar panel to charge a 12-volt automotive type DC battery. As you can see in the distance, there are two small solar panels connected to this meter right here, reading about 12.6 volts. And this meter is connected to the battery, reading 12.36 volts. The goal of my project was to make a solar-powered battery charger that could be left alone for long periods of time without risk of destroying the battery due to overcharging or undercharging. Basically, I wanted something involved with solar power. I've always been interested in renewable energy sources, and I thought this would be interesting to use solar to do something to meet the requirements for completing my project. Here's a closer look-up of inspection of the actual board and the components. I'll go through and explain each one. Right here is the voltage regulator for the powering of the microchip. Because we have 12 volts coming off the battery, we need 5 volts to power the PIC chip. And this reduces the 12 from the battery to 5. The two capacitors are connected to the input and output sides of the regulator and then to ground. Right here on either side to power 5 volts on either side of the PIC chip. We have a capacitor connected between positive and ground. Here we have a bidirectional LED attached to in series with a 220 ohm resistor, which indicates either red or green for either charging or not charging of the battery. Next we have the 2N7000 N-channel MOSFET, which controls the larger P-channel power MOSFET, the IRF5305. Basically, 5 volt output from the PIC chip is not enough voltage to completely shut off the larger IRF5305 connected to the heatsink here, the P-power MOSFET. So the 2N7000 acts as a sort of a voltage translator, which provides basically an on-off switch to our P-channel power MOSFET. The power MOSFET, when it is closed, the purple wire is from the solar charger, the red is from the battery. Basically, those are connected, and the solar panel is actually charging the battery. So basically, the resistors right here are each in series, and in the section here in the center, basically the voltage divider creates approximately a 1 to 2 volt voltage input to the analog ports of the PIC chip. So analog port A, pin 0, would have this input from the solar panel, and port A, pin 1, would have the one next to it, the voltage divider circuit, input from the battery. So basically, right now we have 12.37 volts coming off our battery. We'd be reading about 1.2 volts at the PIC chip input. As with the solar panel, we have 12.65 volts input, which would be read as about 1.2 volts. Because the PIC chip cannot accept voltages larger than 5, this reduces the voltage and creates a value that can be used with the analog digital comparator. Also note that I added right here a interface with the PIC-Kit3 debugger for the programming of the chip, so the chip can be programmed as it sits mounted in the circuit. So as it sits, my project is not working. As you can see, the LED is not green, which it should be to indicate that the battery is off at this time. The battery is not charging, although it should actually be red because we have 12.6 volts on the solar panel and 12.37 on the battery. Seeing as the solar panel voltage is above the battery and the battery is below 12.8 volts, it would be normally turning on and charging. The issue, I believe, is due to a software error. If I remove the PIC chip and mechanically bypass the switches that switch on the N MOSFET and the P channel power MOSFET, the circuit will start charging, as well as the green and red LEDs will illuminate. Also, the heatsink is used for dissipating the heat that will come off the power MOSFET, as the circuit can charge up to 14 amps when into full sunlight with a larger solar panel attached. It would actually charge quite a bit and create quite a bit of heat. So I have some things to work on with my code, and hopefully that will get things running. Thanks for watching. Bye.